Okay, so you're probably wondering, maybe looking at that unit outside, how much longer is my AC or heat pump actually going to last? It's a fair question.
It is a really common one. It's a big piece of equipment, expensive, and
So for this deep dive, that's what we're digging into. We want to unpack it all for you.
yep, we'll hit the typical lifespan, why older units eventually need replacing, common problems you see.
And the signs, the real telltale signs that it's time.
Right. And also the benefits, what you actually gain by upgrading. It's not all bad news.
Definitely not. And to make sure we're getting it right, we've pulled insights from Peter. Good practical knowledge there.
Yeah, and we also looked at resources like Energy Star and Train, kind of the industry benchmarks.
So our goal here is pretty simple.
Hmm.
Give you that mix of, let's say, technical know-how, but also the practical advice you can actually use.
Think of it as your quick guide to feeling pretty confident about your home comfort system decision.
Okay, let's jump in. Lifespan. What are we generally talking about?
Okay, so broadly speaking, for a central AC or heat pump in most homes, you're typically looking at a range of, say, 10 to 15 years.
10 to 15.
Okay, it's the average window.
Yeah.
Now, obviously, some might, conk out a bit earlier. Others might surprise you and keep checking along past 15.
But that 10 to 15 years, that's the sweet spot to keep in mind.
It's a good rule of thumb, yeah.
All right, so that's the ballpark. But what makes one system die young versus another living to a ripe old age? What's the biggest lever there?
Maintenance. Hands down, that's the biggest factor you control. Peter over at PRO Electric plus HVAC really hammered this home.
Right. Regular tune-ups, changing filters, that basic stuff.
Exactly. It seems simple,
Yep.
but it makes a massive difference. We're talking potentially pushing a well-maintained system closer to 20 years.
Wow, okay.
But if you neglect it, yeah, you could see major failures in under 10 years, easily.
And then there's usage, right? How hard you run it.
Yep, and climate.
Mm-hmm.
That plays a huge role, too.
Makes sense. Like here in Northern Virginia,
Hmm.
those brutal summers, AC running constantly, then maybe the heat pump working hard in the winter, too.
Precisely. That adds up, all that wear and tear. And, heat pumps, since they do double duty, heating and cooling,
Yeah.
they often land in that same 15-year average lifespan ballpark as ACs.
Mm-hmm.
Maybe a bit more wear because of year-round use, but again, maintenance is the key.
Gotcha. Now, something I found interesting was how the actual technology itself has changed. How does the age of the tech factor in?
Oh, that's a great point. Older models, like from decades ago, they often had shorter lives, maybe 10, 12 years of good service.
Okay.
But the newer stuff, with better materials, designs, honestly, they can realistically hit that 15 to 20-year mark if they're maintained and were sized right to begin with.
So key takeaway for someone listening right now.
It's this. If your system's over 10 years old, it's like middle-aged in HVAC years.
Yeah.
And once it crosses that 15-year threshold, it's kind of living on borrowed time. Doesn't mean it'll die tomorrow.
But the odds aren't great.
Exactly. The chance of trouble just goes way up. Like a car hitting 100,000 miles, you start budgeting for repairs.
Okay, so the system's getting old. Why do we usually end up replacing them entirely instead of just fixing them forever? What breaks down fundamentally?
Right. Critical question. Think of it like cumulative damage. Wear and tear just builds and builds.
Yeah.
And like any tech, HVAC improves constantly.
Yeah.
So even with good care, eventually, efficiency drops, reliability fades. Those core parts, compressor motors, coils, electrical bits, they just wear out from years of stress.
It just reaches a point where it doesn't make sense anymore.
Pretty much.
Yeah.
It hits a tipping point where fixing it again and again is just impractical and definitely not cost-effective long-term.
Like keeping an old clunker car running. Eventually, you just need a new one. What are the specific big triggers for replacement we see most often?
Well, a major one is when those big, expensive parts fail. The compressor, that's the heart of the system, or the evaporator coil.
Those aren't cheap fixes.
Not at all. We're talking thousands of dollars, easily. And sinking that kind of cash into a system that's already, say, 12, 15 years old?
Yeah, it doesn't feel great.
Right. It usually doesn't make financial sense.
Mm-hmm.
As Peter said, you're almost always better off putting that money towards a new, efficient unit with a fresh warranty.
Makes sense. Spending big money just to have something else break next year.
Yeah,
Tough pill to swallow. What about efficiency? Does that just tank over time?
absolutely.
Okay.
It naturally declines. Even if it's still cooling, it might be using way more electricity than it used to.
How come?
Components get dirty, lose effectiveness, maybe tiny refrigerant leaks over years. The basic tech just isn't as good as today's stuff.
Can you give us an idea of how much efficiency drops, like in real terms?
Sure. Think SEER ratings. seasonal energy efficiency ratio. An AC from 15 years back might have been, say, 10 or 12 AC are brand new.
Yep.
For 15 years.
Mm-hmm.
They're probably performing worse than that. Now today, new ACs start at 14, 15 SEER minimum. High efficiency ones, 20 SEER plus.
That sounds like a big difference.
It is. It's like miles per gallon. Lower SEER means you're burning more energy for the same cooling. So if your bills are creeping up, but your usage hasn't changed.
It could be the AC.
Very likely.
Yeah.
Jumping from like a SEER 10 to a SEER 18 could cut your cooling costs significantly. Yeah. Maybe hundreds a year.
Okay. Rising bills, definitely a red flag. Now, the refrigerant thing, Freon, R22, I hear that's a huge issue now.
Oh yeah, that's critical. If your system is, say, 12, 15 years old or more, high chance it uses R22, Freon. That was standard before 2010.
But they stopped making it, right? Environmental reasons.
Exactly. The EPA phased it out. Production and import ended in 2020.
So what does that mean if you have an R22 system?
It means the only R22 available is recycled stock.
Yeah.
And the price, astronomical.
Oh, wow.
So if your old unit springs a leak, which is common in aging systems, corrosion, vibration, just recharging it with R22 can cost a fortune, sometimes hundreds per pound. Peter mentioned some quotes they give are just shocking.
So a leak basically forces your hand.
Often, yeah. The cost of R22 makes people decide, okay, time for a new unit using modern refrigerants like R410AA or the newer R454B. They're available, cleaner, way cheaper.
Can you just switch the refrigerant in an old unit?
Not really practical. Different pressures, system design. Retrofitting usually isn't the way to go. So yeah, an R22 problem often means replacement is the logical move.
Okay, so we've got repair costs, bad efficiency, the whole R22 mess. What else pushes people towards replacement?
Just breaking down more often.
Yeah.
After about 10 years, it's common to see more frequent problems. Capacitors, fan motors, contactors. Smaller stuff, but adds up.
Right, one thing after another.
Exactly. Maybe one repair isn't crazy expensive, but if you're calling the tech every season or multiple times a year, that system's telling you something.
He's waving the white flag.
Pretty much. It's nearing the end.
Yeah.
Problems will likely keep popping up.
I think I heard about a kind of rule of thumb for deciding, like, repair versus replace based on cost and age.
Yeah, the $5,000 rule is a common one.
Okay.
Basically, you multiply the system's age in years by the repair cost estimate.
Okay.
If that number's over $5,000, replacement is probably the better financial bet long term.
Give me an example.
Sure.
Yeah.
10-year-old system needs a $600 repair. 10 times 600 is $6,000. That's over the $5 K threshold.
Yeah.
Suggests replacement might be smarter.
Okay. It's not a strict law, but a guideline.
Exactly. A useful framework. Because the hassle and cumulative cost of constant repairs on an old unit often just isn't worth it compared to a new reliable one.
Makes sense. And warranties must play into this too, right? When they run out.
Absolutely. Most manufacturer warranties are around 10 years if it was registered properly.
You're right.
After that, any big repair is completely on you.
Out of pocket.
Totally. Plus, for really old units, finding the right parts can get tricky. Or expensive. Parts become obsolete.
So you might not even be able to fix it easily.
Sometimes.
Yeah.
Or it requires a costly workaround. So no warranty plus parts becoming scarce. That definitely pushes the decision towards replacement.
Wow. So by the time you hit that 10 to 15 year mark, it feels like a perfect storm brewing. More breakdowns likely, efficiency dropping, maybe R22 issues, parts harder to find.
That sums it up pretty well.
Yeah.
The signals get pretty clear. Continuing to dump money into it often feels like, trying to keep that old car alive.
Yeah.
Eventually, new and reliable just makes more sense.
Okay, we've covered why they often need replacing. Let's dive into the specific problems you see with older gear. What starts to go wrong?
Well, simple wear and tear is huge. After thousands of running hours, fan belts crack, motor bearings wear out, makes them noisy, less efficient.
Right.
The compressor itself, the main engine, it starts to struggle. Might draw more power as it ages. You might notice it short cycling, turning on and off too quickly.
That's bad, right?
Not good for longevity, no. Or it just runs louder than it used to. Maintenance helps catch stuff early, but parts will eventually wear out and fail. And like Peter said, if it's already had multiple repairs, more are probably coming.
Makes sense. What about that efficiency loss we talked about? What's physically happening?
Several things. Those coils, indoor and outdoor, they get dirty, corroded, especially in humid places. That layer acts like insulation, makes it harder to transfer heat.
Okay.
The refrigerant level might drift off optimal due to tiny leaks over years. Internal pressures change. Lubricant breaks down. It all just makes the system less efficient at moving heat.
And you can't just, like, tune it back up to new.
Not really, not on a 15-year-old unit. Newer models have better tech, fundamentally scroll compressors instead of old piston types, variable speed fans,
Yeah.
core design improvements older units just lack.
Gotcha. And refrigerant leaks, we covered R22 how, but even newer systems can leak as they age,
Oh
right?
yeah, R22 systems are prone, especially coil corrosion or vibration leaks. We see tiny leaks in indoor evaporator coils a lot, slow escape of refrigerant.
Leads to poor cooling. Freezing up.
Can do, yeah. And again, R22 top-offs are brutal. But even newer R410A systems can develop leaks. Finding and fixing a big leak often means replacing the whole coil. Still a major expense.
So any leak in an older unit needs careful thought.
Definitely. Weigh the repair cost against the system's age and likelihood of future problems.
What about electrical gremlins? Lots of wires and stuff in there.
For sure. Heat, regular use,
Yeah.
it takes a toll. Capacitors failing is super common. They help start motors. Contactors, the switches, they get pitted or stick.
Causes tripping breakers. Or just not turning on.
Yep. Corroded wires, loose connections too. Replacing one capacitor isn't awful, but if electrical stuff keeps failing, that's a sign of overall aging.
Like the whole system is just getting tired.
Pretty much. And sometimes motors just burn out. That's a bigger deal. Frequent electrical fixes mean the end is likely near.
Okay, mechanical, electrical. What about sounds and smells? Are those warnings too?
Absolutely. Huge clues. A healthy system is relatively quiet. Older units, you might hear rattling, buzzing, grinding, squealing.
Not good sounds.
No. Often worn bearings, loose parts, struggling compressor could mean a big failure is coming. And smells, never ignore weird smells.
Like what?
Musty odor from vents. Could be mold inside from drainage issues. Burning smell, serious red flag. Overheating motor, wiring problem. Needs immediate check.
So these aren't just annoyances, they could be serious signals.
Especially in an older unit, yes. They often point to general decline. Might be wise to replace before it totally dies on you.
And lastly, just comfort, if the house isn't comfortable anymore.
Definitely a sign. Maybe some rooms are way hotter or colder than others, even though it used to be even.
Why does that happen?
The system loses capacity over time. Wear and tear. Can't cool or heat as effectively. Also, older ACs often struggle with humidity removal. Air feels sticky, clammy, even if the thermostat says it's cool.
Right, the dehumidification aspect.
People forget how much ACs do that until they start doing it well. So, poor comfort, hot-cold spots, humidity issues. All strong signals the system is struggling and nearing the end. Plus, newer systems offer much better air cleaning too.
Okay, so lots of potential problems with older gear. Now let's nail down those really clear signs. When is it really time to think replacement, not just another repair?
All right, key indicators. First, simplest one, age. We keep saying it, but if your AC or heat pump is 10 to 15 years old or older,
It's prime time to evaluate.
exactly, it's operating on borrowed time, efficiency is likely way down. Energy Star actually suggests considering replacement at 10 years just for the efficiency gains. By 15, most should probably be retired.
Okay, age is number one. What's next? What screams replace me?
Frequent breakdowns, needing repairs all the time.
Yeah.
Think back last couple of years, how many service calls?
Yeah.
An occasional fix, okay, but every season, multiple times a year, that system's in distress. It's unreliable.
And the costs add up.
Hugely.
Yeah.
You might have already spent a big chunk of a new system's cost just patching the old one. Remember that $5,000 rule? Helps here.
Right. Age times repair cost.
Yep. If you know your HVAC tech's birthday, because they're over so often, it's probably time for a new system.
Huh. Good point. Okay, what else was another big flag?
Those skyrocketing energy bills we talked about. A significant, consistent jump in your utility costs during peak seasons.
And you haven't changed habits or rates haven't spiked?
Exactly. Then your aging HVAC is the likely culprit. It's working harder, running longer, burning more energy. Compare with neighbors sometimes, it can be revealing.
If it runs constantly but still struggles.
Oh yeah. Definitely using way more juice than a newer model would. Big sign.
We also mentioned comfort problems earlier. How strongly do those point to replacement?
Very strongly. If it just can't keep the house consistently comfortable anymore, that's a core job it's failing at.
Hot spots, cold spots, can't reach the thermostat setting.
Right. Especially on really hot or cold days. Running constantly, but never satisfying the thermostat. Uneven temps, humidity problems, classic signs of an aging system losing capacity. Newer systems, especially two-stage or variable speed, are much better at consistent comfort.
Okay. What about those noises and smells again? When do they cross the line from annoying to replacement signal?
You should never ignore them, really. Loud rattling, buzzing, grinding, banging, hissing. Points to failing parts, often expensive ones like motors or the compressor.
Especially in an old unit.
Exactly. Burning smells, musty smells, serious warnings. While may be fixable sometimes in an older system, they often mean widespread decline. Might be smart to replace proactively before total inconvenient failure.
And we have to circle back one more time to R22 Freon. That's almost an automatic trigger, isn't it?
It's a huge factor, yeah. If your system uses R22, check the nameplate outside. That alone is a massive reason to seriously consider replacement.
Because of the cost and availability.
Precisely. Obsolete, crazy expensive, hard to get. If it develops a leak now, you face potentially massive repair bills just for the refrigerant. Many people with R22 systems choose to replace proactively just to avoid that potential shock.
Smart move. Okay, last point here. Any general financial rules besides the $5 K1 for weighing repair versus replace?
Yeah, that other common guideline. If a major repair estimate comes in at more than, say, half the cost of a whole new system,
Replacement is probably better.
generally, yes. Sinking, say, $3,000 into repairing a 15-year-old unit when a new one might cost $6,000 or $7,000.
Yeah.
It often doesn't make long-term sense. Other parts could fail soon after.
Right. Put that money towards new, warranted, efficient equipment instead.
That's the usual logic. You get lower bills, reliability, warranty, peace of mind.
So if you're ticking boxes here, age over 10, 15 years, frequent breakdowns, rising bills, comfort issues, it really sounds like investigating replacement is the next logical step.
Absolutely the right takeaway. The goal is to avoid that point of diminishing returns, constantly throwing money at an old, inefficient unit that still doesn't keep you comfortable or reliable.
Okay, we've made a strong case for why replacement happens. Let's flip it. Talk about the good stuff. What are the real benefits when you do upgrade to a new AC or heat pump?
The upside. And there are significant benefits. It can really improve your home life and save money over time. Big one. Energy savings.
We touched on that, the SEER ratings.
Exactly. HVAC tech has improved massively. An old unit, pre-2010 maybe, way lower SEER than even today's minimum standard, let alone high-efficiency models.
So the savings can be substantial.
Oh, yeah. The Department of Energy estimates upgrading a 10-year-old AC can save you 20% to 40% on cooling costs.
Wow, 20 to 40%.
Yeah. Think about that adding up month after month, year after year. It really helps offset the initial cost. Plus, less energy use is better for the planet.
Lower bills are always good. What about reliability? Fewer breakdowns?
Definitely. New system means a new warranty, usually 10 years on parts if registered. Huge peace of mind.
No surprise repair bills for a while, hopefully.
Right. Compared to an old unit nickel and diming you, a new one should mean far fewer service calls initially, besides basic maintenance. It's investing in dependability, especially when you really need it in extreme weather. Think of the repair costs you avoid.
Good point. And comfort, you said new systems feel better.
Much more consistent cooling and heating. Many new systems have two-stage or variable speed tech.
What does that do?
Lets them run at lower levels for longer periods. Gets rid of those temperature swings, hot-cold spots you get with old on-off systems.
Okay.
They're also way better at controlling humidity, so the air feels less sticky in summer. Plus, compatibility with smart thermostats, better sensors, gives you much finer control.
What about noise? Some old units sound like jet engines taking off.
Yeah, another area with big improvements. Manufacturers worked hard on quieter designs, new compressors, fans. Some high-end units are really quiet now, like conversation level.
Nice.
Homeowners are often really surprised how much quieter the new system is, inside out. Just makes the home more peaceful.
Sounds like it's more than just heating and cooling, air quality too.
Yep, big improvements there. Modern systems integrate much better with advanced filters, media filters, electronic air cleaners, UV lights.
What do those do?
Capture way more dust, pollen, dander, even some germs. Great if you have allergies or asthma. Some high-end systems even have smart diagnostics, talk to your phone, remind you about maintenance.
Cool. Smart feature.
And smart thermostat compatibility gives you remote control, energy-saving schedules, lots of convenience.
Lastly, any help with the upfront cost? Rebates or anything?
Absolutely. Always check for federal, state, local utility rebates or tax credits, especially for high-efficiency units or heat pumps.
They can make a real difference.
Sometimes significant offsets. Plus, HVAC companies often run promotions or offer financing. When you add potential rebates to the long-term energy savings, the cost looks a lot more manageable.
So pulling it all together, replacing an old system isn't just fixing a problem. It sounds like it's often the smartest, most comfortable, and most cost-effective move long-term, even with the initial price tag.
That's the key idea. The upfront cost is real, but weigh it against ongoing energy savings, avoided repairs, better comfort, quieter operation, better air quality. It becomes a really worthwhile investment when that old system hits the wall.
Okay, so wrapping up this deep dive, let's hit the highlights one last time. Typical lifespan, generally 10 to 15 years. Keep an eye out for those warning signs we talked about.
Right. And remember why replacement becomes necessary. Efficiency drops, major parts get expensive to fix, old R22 refrigerants is a nightmare, and repairs just become more frequent.
But the good news, upgrading brings real benefits. Lower energy bills, fewer repair headaches, way better comfort, quieter operation, cleaner air.
And maybe some rebates to help pay for it.
Exactly. So here's a final thought for you listening. Really weigh the long-term picture. What's your current system costing you? Not just in bills, but in hassle and comfort versus what a new system could offer.
And if you're unsure, get a pro involved. A trusted local HVAC contractor can give you an honest assessment. Seriously, making a planned replacement decision when you have time to research.
Way better than a panic decision when it dies mid-heat wave.
Absolutely. Proactive is always better than emergency reactive in this game.